Getting started with Python and variables. Welcome to an exciting journey into the world of Python programming. Whether you're an aspiring software engineer just starting your coding adventure or an IT student looking to solidify your foundational knowledge, this video is designed for you. Python is a powerhouse language, celebrated for its readability, versatility, and extensive applications across web development, data science, artificial intelligence, and automation. Its gentle learning curve makes it an ideal first language, yet its capabilities are boundless, powering some of the most complex systems in the world. In this comprehensive tutorial, we're going to demystify the initial steps, from setting up Python on your machine, to writing your very first program, and then diving deep into the fundamental concept of variables. Variables are the unsung heroes of programming. They are how we store and manipulate data, allowing our programs to be dynamic, interactive, and intelligent. By the end of this video, you'll not only understand Python's basic syntax but also grasp how to work with different data types like strings, integers, floats, and booleans, enabling you to build interactive applications that can store user input and display information back. Let's embark on this coding adventure together and unlock the power of Python. Our first crucial step is to get Python installed and ready on your system. Think of it like preparing your workbench before you start building anything. The easiest and most reliable way to do this is by visiting the official Python website, https://www.python.org/download/. Here, you'll find the latest stable version of Python available for your operating system, whether you're on Windows, Mac OS, or Linux. Take a moment to download the appropriate installer. As you proceed with the installation, particularly if you're a Windows user, pay close attention to a small but incredibly important checkbox that says, Add Python to Path or Add Python.exe to Path. Checking this box is absolutely vital, as it allows you to run Python commands directly from any command prompt or terminal window, saving you a lot of hassle later on. Once the installation is complete, open your command prompt or terminal and simply type Python version or Python 3 version. If you see a version number like Python 3.9.7 or similar, congratulations. Python is successfully installed and ready for your first program. If not, double-check the installation steps, especially the path configuration. With Python successfully installed, it's time to write your very first lines of code. You can use any simple text editor, but for a better experience, I recommend an integrated development environment, IDE, like VS Code, which offers excellent features for Python development. Open your chosen editor and create a new file, saving it as main.py. The .py extension is crucial, as it tells your operating system that this is a Python script. Now, let's introduce our first Python function, print. This function is your primary tool for displaying output to the console. To print a message, you simply put the text you want to display inside the parentheses, enclosed in either single quotes or double quotes. For example, following along with our main.py file, you can type, print, hello, Python learners. Print, welcome to your first Python program. And print, let's explore variables. Once you've saved these lines, navigate to the directory where you saved main.py using your command prompt or terminal. Then, simply type Python main.py and press enter. You should see your messages instantly appear on the screen. This is your program running, and you've just executed your first Python script. It's a small step, but a monumental one in your coding journey. Now that you've successfully run your first Python program, let's introduce a concept that is absolutely fundamental to any programming language, variables. Think of a variable as a labeled container or a named storage location in your computer's memory. Just like you might have a box labeled toys or books to store specific items, variables are used to store different pieces of data within your program. This data could be anything from a user's name, a numerical score, or even a true/false condition. Why are variables so important? Because they allow your program to be dynamic. Instead of just printing static text, variables enable you to store information, retrieve it, modify it, and reuse it throughout your program's execution. This makes your code much more flexible, efficient, and readable. A fascinating aspect of Python is its dynamic typing. Unlike some other programming languages where you have to explicitly declare the type of data a variable will hold, e.g., int age, or string name, Python automatically infers the data type based on the value you assign to the variable. This simplicity makes Python incredibly beginner-friendly, allowing you to focus on the logic rather than rigid syntax rules. Let's dive into the first specific type of data we can store in variables: strings. In Python, a string is simply a sequence of characters, essentially text. Whether it's a single letter, a word, a sentence, or an entire paragraph, if it's text, it's a string. Python gives you the flexibility to enclose strings in either single quotes or double quotes. Both work identically, so you can choose whichever style you prefer, as long as you're consistent within a single string. Looking at our main.py file, you'll see examples like student_name equals Alice Smith and course_name equals Introduction to Programming. Here, student_name and course_name are variables holding string values. To display these values along with other text, Python offers a powerful feature called f-strings, short for formatted string literals. They start with an F before the opening quote, like print, F, student name, student_name. Inside an f-string, you can embed variable names directly within curly braces, and Python will automatically substitute them with their current values. You can also join strings together, a process called concatenation, using the plus operator, as demonstrated by full_greeting equals hello, plus student_name plus. Welcome to plus course_name plus, dot. Strings are fundamental for any program that interacts with text data, from displaying messages to processing user input. Moving on from text, let's explore how Python handles whole numbers. For this, we use integer variables, often simply referred to as ints. An integer is any whole number, positive, negative, or zero, without any decimal component. Think of counts, quantities, or scores. In our main.py example, you'll find student_age equals 20, number_of_ assignments equals 5, and total_score equals 450. These variables are all holding integer values. Integers are incredibly versatile and are frequently used in mathematical operations. Python allows you to perform basic arithmetic directly on these variables. For instance, if number_of_ assignments is 5, and we want to calculate assignments_remaining after a student completes 2, we can write assignments_remaining equals number_of_ assignments, 2. When you print assignments_remaining, you'll see the result, 3, automatically calculated. This highlights the power of variables. They don't just store static values, but can be dynamically updated and used in computations, making your programs capable of complex calculations and logical processes that adapt to changing data. Understanding integers is crucial for building any program that deals with numerical quantities or counts, from game scores to financial calculations. While integers handle whole numbers, what about numbers that require a decimal point? For these, Python uses float variables, short for floating point numbers. Floats are essential when you need precision, such as in scientific calculations, financial applications, or when dealing with averages and measurements. Examples from our main.py include average_grade equals 88.75, GPA equals 3.8, and the mathematical constant pi_value equals 3.14159. Notice the decimal point in each of these values. That's what makes them floats. Just like integers, floats can be used in arithmetic operations. However, a key difference often arises with division. For example, if we perform half_GPA equals GPA/2, even though GPA is 3.8 and 2 is an integer, the result 1.9 will inherently be a float. This is because division in Python typically yields a float to maintain precision, even if the result could be a whole number. This distinction is important to remember, especially when building applications that require high precision or mixing different types of numbers in calculations. Floats empower your programs to handle real-world measurements and values that aren't strictly whole numbers, opening up a vast range of applications. Now, let's introduce a data type that's deceptively simple yet incredibly powerful: boolean variables. A boolean can only hold one of two values, true or false. These are not strings. They are special keywords in Python and must be capitalized. Booleans are the backbone of decision-making in programming. They represent conditions. Is something true? Is something false? For example, in our main.py script, we have is_enrolled equals true and has_completed_course equals false. These variables clearly state the current state of a student's enrollment and course completion. The true power of booleans becomes apparent when used in conditional logic, particularly with if statements. The line if is_enrolled